Last time I taught, we figured out the vertex using a standard form equation where we ended up finding the roots. If I had y equals x squared, let's say minus 6x plus minus 16, does that factor? Well, we use the box. We stick x squared in, and we stick negative 16 in, and we multiply those, and I get negative 16x squared. And I'm looking for numbers that multiply to be negative 16 and add to be negative 6. Are there any? 2 and negative 8. And it's actually 2x and negative 8x. I put 2x in one box and negative 8x in another. What does the top row share? X. And if I take an x out of both of those, what am I left with? X plus 2. And if I take an x out of both of these, I'm left with x minus 8. So the factors are x plus 2 and x minus 8. What are the roots? X equals negative 2 and 8. If I graph that, we hit here at 2 and here at 8. Does this parabola open up or down? Up. How do you know? This number is positive. Okay, we just need to figure out where is the vertex. And we do that by finding the axis of symmetry. Where is the axis of symmetry in relation to the roots? We know that the parabola is going to look something like this. Where do we find the axis of symmetry if we know where the roots are? It's going to be halfway between them. And to find a halfway point, you just take an average. So add negative 2 plus 8, and I get 6. Divide that 6 by 2, and I get negative 3. Oh, I graphed it wrong. I'm sorry, guys. Sorry. It's negative 2 and positive 8. So my graph is going to look something like this. And if I go over to x equals 3, that's the axis of symmetry. So the axis of symmetry is x equals 3. How do I find the vertex? I plug 3 into the equation. I know the x value is 3, so down here I'm going to put 3 in there and 3 in there. 3 plus 2 is 5, and then 3 minus 8 is negative 5. What is positive 5 times negative 5? Negative 25. So way down here, this point is 3 comma negative 25. And that's how you find the vertex and the axis of symmetry if you have a standard form equation. Factor it, take the factors and find the roots, add the roots together and divide them by 2, and that will tell you where the axis of symmetry is. Take that value and plug it into the equation, and that will tell you the y value of the vertex. Does that make sense? Okay. Now we need to solve. It says find the zeros. If I had f of x is 1/3 times x minus 4 times x plus 1, what are the zeros of that function? What is a zero? A zero is just a root. It just wants to know, where does this graph hit the x-axis? Well, it's really easy. What is the root for that one? X equals 4. What's the root for this one? -1. So that problem is very simple. What if I have x squared minus 17x plus 52? I need to use the box. X squared and 52, multiply those together, 52x squared, and I'm looking for the factors of 52 that add to be -17. I recommend that you look for these in order. Do 1 and 52 work? Nope. 2 and 26, do they work? 3 does not go into 52. 4 and 13, do those work? Yes. I put 4, or sorry, if they're both negative. -4x in one box and -13x in another. What does the top row share? X. And if I take an x out of each of those, x minus 4. If I take an x out of each of these, I get x minus 13. So what are my roots? 4 and 13. Okay. All right, what about this one? -4x squared minus 8x minus 4. I need to divide it out a -4. You guys get this, or are you not paying attention? So pull out -4. X squared plus 2x plus 1. Now I draw the box. X squared and 1. Multiply those together, and I just get 1x squared. Are there factors of 1 that add to be 2? 1 and 1. 1x and 1x. The top row shares an x. If I take an x out, what's left? X plus 1. And if I take an x out here, get x plus 1. So my roots are -1 and -1. Wait a minute. Can a parabola hit the x-axis in the same place twice? Yes. How does it do that? How does a parabola hit the x-axis twice at the same place? Well, it looks like this. So I want to show that it can hit twice. If I had this parabola, it has 2 roots. And as I move it up, 2, 2, 2, 2, but right there, those 2 roots have become 1 root. And it bounces off the x-axis. So what's happening is, as this parabola comes down, it hits that point and then bounces off. We call that a double root, or a root with multiplicity 2, meaning the same root happens twice. Okay? Now, for future information, if this is a single root, then the graph just goes straight through it. If it's a double root, then you get a bounce. If it's a triple root, like x equals 2 and 2 and 2, then the graph does this. If it's a quadruple root, then it bounces, but it's super steep. So a root can happen as many times as you want it to, and if it happens an even number of times, then it bounces. If it happens an odd number of times, then it just kind of flies right through it. Okay. So you have some match with the graphs. Okay. What if I had this? y equals x plus 1 and x minus 3. And I want to graph this. What do I know about this function? It hits at -1 and 3. So -1 and 3. These are my roots. What else do I need to figure out how to graph that? I just need the vertex. So in order to find the vertex, I need the axis of symmetry. How do I find the axis of symmetry? Well, I have the root x equals -1 and x equals 3. Add those together. 3 minus 1 is 2. Take that 2 and cut it in half, and I get 1. So the axis of symmetry is right here. The AOS is x equals 1. Now what? Plug 1 into the equation, and 1 plus 1 is 2, and 1 minus 3 is -2. 2 times -2 is -4, so I go down to -4, and that's what the parabola looks like. Okay? Y equals -3 times x minus 4 times x minus 8. What do I know about this parabola? The roots are 4 and 8. X equals 4 and x equals 8. So it hits here and it hits here. Now I need to find the halfway point. What is halfway between 4 and 8? 6. The axis of symmetry is x equals 6, right here. Okay. Then what do I do? Plug 6 into the equation. I put a 6 here and a 6 here, and I get -3 times 6 minus 4 is 2, times 6 minus 8 is -2. -3 times 2 is -6, and -6 times -2 is -12, or sorry, +12. I go up 12. And the graph looks like that. Does that make sense? Okay. Where are my roots? -2 and 7. So -2 is right there. 7 is right there. What about my axis of symmetry? Add them together and divide by 2. What is -2 plus 7? 5. 5 divided by 2 is 2.5. So right here, my axis of symmetry is x equals 2.5. Then I need to put 2.5 in there. And I'm going to use my calculator. I don't want to do this in my head. 1/4 times 2.5 plus 2 times 2.5 minus 7. And it gives me -5.06, which is just a little bit below -5. If I go down, so here's the line for 5. It's going to be slightly below that. And it would look like this. Does that make sense? Okay. That takes us all the way up to 39. In the next set, you just have to find the mistake. So 41, there's a mistake that you need to figure out. And then 43 to 54, it says write a quadratic in standard form whose graph satisfies the given conditions. So we want a quadratic. You know what? I'm not sure we want to do that. Passes through. Do I want to do that? That's the question. Let's say that I had these points, -5, 0, -1, 0, and -4, 3. These are both roots. Agreed? If I graph this, I left 5 and left 1, and then -4 up 3. Does this parabola open up or down? Down. I could draw it like this. And I know that it's going to be y equals a times x minus one of the roots times x minus the other root. So for this equation, my roots are -5 and -1. I'm going to write down y equals a times, what is x minus -5? X plus 5. And what is x minus -1? Does that make sense? The only thing I don't know is a, but I do know something about a. Is a positive or is a negative? A is negative. What I do is take this point here, which is -4, 3, and that's an x and a y, and I plug it in. I'm going to plug this in for x, and I'm going to plug this in for y. 3 is equal to a times, what is -4 plus 5? 1. What is -4 plus 1? -3. 3 equals, what is a times 1 times -3? -3a, and I divide by -3, and I get a equals -1. What do I do with that -1? Just put it in for a. The equation is y equals -1 times x plus 5 times x plus 1. Okay, that's the hard way. If you understand that, go ahead and do that the hard way. The easy way is with your calculators. So pull out your calculators. What we need to do is plug all of these points into our stat. And I'm going to put them in a table so you can see how it's supposed to look. x, and y. It doesn't matter what order you put the points in. You just have to make sure that each x is connected to the appropriate y. If you push stat and you go to edit, and then if you want to clear a list, go up to L2 and push clear. And go up to L1 and push clear. And then in order to write a quadratic equation, you need 3 points. If you try to do a quadratic equation with 2 points, then it will give you an error. For my x's, I have -5, -1, and -4. For the y's, I have 0, 0, and 3. Anybody not know how to do that? Once I have those entered, I need to go to the calculate page. If you push stat and go to calc, we want to do number 5, which says quadratic regression. Now don't confuse number 5 with number 7. We want quadratic regression. We don't want quartic regression. I push number 5, and then I have to go all the way down to calculate. Some of you just need to push enter. And I end up with A equals -1, B equals -6, C equals -5. What should I do? What does that mean? It means y equals -1x squared minus 6x minus 5. Does everybody understand that? Okay. Well, what if um, we had the vertex equals 4, 8? I want an equation whose vertex is 4, 8. I go left or right 4 and up 8. Does that parabola open up or down? It doesn't tell us. It can open up or it could open down. So there are an infinite number of correct answers in this case. In order to graph it, I need 3 points. In order for the calculator to tell me the function, I need 3 points. So I need to pick 2 other points. What would be the easiest 2 points to pick? Well, let's decide. Do we want it to open up or do we want it to open down? Down, okay. If it opens down, what are 2 really easy points to pick to create a quadratic? What's that? So we could have 2, 0, this one, and so if it came down here and it went over 2, then we'd go over 2 there. I could say 2, 0 and 6, 0. That would work. I would probably just go over 1, down 1. That would also work. I might say 3, 7 and 5, 7, but it doesn't matter. It doesn't matter what 2 points you pick as long as they're evenly spaced so that the vertex is at 4, 8. And then you just plug those 3 numbers into your stat and then do quadratic regression and it will spit out the equation. Okay? All right. What if it drew a graph and the graph looked like this, And this point right here is 6 comma 5. What would I put in my stat in order to figure out this equation? What would my x values be? 6 is one of them. 1 and 7. What would the associated y values be? 5, 0, and 0. And then I just go back in, calc, do quadratic regression, and it spits out the equation y equals negative 1x squared plus 8x minus 7. Okay, can you handle that? So we stopped. We did 3 through 20 all, right? I want you to do 21, 21 through 59 odd. 21 to 59 odd is the rest of the assignment.